Okay, so I've gone ahead and consolidated and put all of the descriptive statistics we've calculated using JASP so far into a Word document so I can draw on it. I've highlighted where you can find the means and standard deviations from the descriptive statistics table for both the shorter half of the class and the taller half of the class because we use some of that information in our models. And I've drawn the models, I've put them side by side. So again, your models don't have to look exactly like mine because we don't know exactly what that population looks like. But using the data we have, this is kind of my best guess, right? This is sort of, okay, this is what I think is likely going on based on the data that we already have. So you can see the model that I built for the short half of the class with the shape, the center around 51.7-ish, and the spread of about 6.1. So using this modelese general sort of formula where our dependent variable, in this case thumb, is centered around the mean, but if we're like guessing for any particular thumb, we would guess maybe plus or minus within a certain amount, right? So I'm using that to create the modelese for my short half of the class, so shorter people model, and a model for taller people, the taller half of the class. So here, the short model, the short half the class model, I predict that shorter people, their thumb length is centered, the center of that population is somewhere around 51.7. That's what I think. But I also think that the spread of the data around that point, I think the average spread is about 6.1 based on what we know. So if somebody knew where to come into the class, and I might guess 51.7 because close to 51, 52 is, probably about right based on this population. But then again, it could be, reasonably as low as 6 lower, like 45, 46. Or maybe it's a bit higher. Maybe they're a little taller of a short person. And so they're up on the right-hand side. And so theirs could be maybe up around 58 or so, right? So it sort of gives us what we consider a kind of reasonable range, right? We start with our best guess at the center, but then from there we also recognize that it's not going to be exactly the center. It's probably going to be about between these two values based on how spread out our data are. Okay, so I went ahead and did the same thing for the taller half of the class. I have the feeling that this population, it actually does kind of go down here a bit more. Like there's probably a few people out there and we just didn't get lucky just based on the shape. But it also may be just that it's a little bit skewed. So again, yours may look different from mine. I centered mine around the mean. The mean from the sample was 57.88. I figure the spread is going to be around 7.94 because that's the spread of the sample. So I'm guessing taller people probably have a little bit more variation in how long their thumbs are. I don't know. And the tall model that I came up with was, okay, so tall people's thumbs, I'm thinking their thumb is, if I know they're from the tall half of the class, I'm going to guess higher. I'm going to guess around 57.9, 58. But if they're in the taller half of the class, I also know there's a little bit more variation. There's a little bit more variability or spread in those values. So it may be as low as like 50 or as high as whatever, 58 plus about what, 66, right? So I might even expand this a little more. And that's what I consider to be probably about the spread of my population. The average spread is probably somewhere around 7.9. So the thing is, here we've taken one class and we've split it into these two separate models. We have a model for people who are on the short half of a class and model for people who are kind of on the tall half of a class. But that's kind of weird, right? And now we have these two separate models. Like, wouldn't it be nice if we could smush them together somehow so that we have just one model? Because what happens if we split it further? Like, do we have, if we split it, and one of the next problem is going to talk about, if we split it so that instead of just two groups, we have four groups, then are we going to have four models? Like, maybe each model is getting a little better for that group of people, but like, where do we stop? Are we just going to have models and models and models? Where, why doesn't everyone just get their own model? And then what's kind of the point, right? And so we go down the rabbit hole. So we don't really necessarily want to, in this case, split it into short half and tall half. We want to kind of keep it together all in one model if possible to describe all of the people in this class using one model. So just go ahead and follow along with me here as I talk through this. So to create this one model, I want to sort of, I mean, if we look at the shapes and the spreads, they're not that different, right? They're not too different from each other. So I think that they both follow generally the same kind of model. But I think if we could just sort of, let's say, okay, thumb length, because again, we're talking thumb as dependent variable. Now follow along with me here. I'm going to start with the lower of my two models. So let's say, okay, well, I think the general population, there's a center around 51.7. And I'm just going to put out here because I know there's going to be some error. And that error is honestly, based on these numbers, it's probably somewhere between like 6 to 8, right? If we were really to find it for the whole population. And so let's look. So we have this mean plus the error, but how is this different from just the short model? We need to adjust it to sort of account for the tall model as well. So what I'm going to do, and this may sound a little confusing right here, bear with me. I'm going to say, okay, so I need to do some sort of adjustment to account for the tall people. If it's the short people, I don't want to change anything, right? I want to leave it as is. So I'm going to say, well, if they're short, add 0 because it's already where I want it. But if they're tall, this guess is going to be too low. It's going to be too low by about how much? So I'm going to round a little bit here. Actually, let's see. Let you in on a little secret here. I am not very good at math in my head. I'm good at the concepts, not so good at doing what a calculator could do. Okay, which is thank you. We have calculators. Okay, so I'm just looking for what's the difference between the mean of our taller group and the mean of our shorter group. It's probably going to be around what, 6-ish? Yeah. So if they're short, don't change the thing. It's perfect. But if they're tall, we're going to want to add a little more than 6. I'm just going to round for space, okay? So now we have this model that's saying, okay, so start around here for guessing, right? If somebody new comes into the class and we want to guess their thumb, well, this is a good starting place if they're short. But if they're in the taller half of the class, if we know that one piece of information, whether they're short or tall, then we can adjust our guess by about 6.2 to account for that difference. So I'm going to sort of just make a little shorthand here. So really to consolidate, we're sort of saying like, okay, if I had to guess this new person's thumb length, so that's where we started with this whole thing, I'm going to say, I'm going to start at 51.7. I'm going to eyeball them and see, do they look like they're in the short half of the class or the tall half of the class? If they're in the short half of the class, I'm not going to change it. I'm going to leave it. But if they're tall, right? So if they're tall, I'll just put in a 1 here. And if they're not, oh wait, I'm rounding a little too much. 6.2, here we go. 6.2 times, like, if they're tall. If they're tall, put a 1 in. If they're not tall, put a 0, and this whole thing goes to 0. Right? So then this will help me to adjust, and I can kind of consolidate it all into one model. And again, plus or minus, we're not going to be right every time. We're probably not going to be right most of the time. We're not going to be exactly on, but hopefully we're pretty close. And we can expect to be sort of within a certain reasonable range based on our model. Based on this model, I would not guess that there are very many thumbs that are 130 millimeters, because even in the tall class, 80 is kind of our high end. So 130 is really, really, I mean, maybe some professional basketball players kind of thing. But it helps to kind of tell us what's a reasonable sort of guess. And if they look a little shorter, we can guess a little lower maybe. If they look a little taller, maybe we're going to guess a little taller. Right? But the goal is to try to build a model to sort of cover it all. We don't want separate models for it all. So we're going to come back to this, both in this classwork and in the next one. So, or in the next, we're going to come back to this idea. So try to keep this in mind. We want to consolidate to one model. And also, wouldn't it be nice while we're at it, wouldn't it be nice if instead of having this graph and this graph, and I have to like do everything twice, it might be nice if I could put them together into one graph. Okay, so I'm going to go ahead and show you how to do that part next here in JASP. So for our next problem, we're going to make a scatter plot of the two variables we've been talking about. So in case you're like, what two variables? We're talking about thumb length, that's our dependent variable. And we're also talking about height median split, whether they're in the short half or the tall half. That's the independent variable in this case, right? So if we look back here, we're sort of saying like this piece where we're like, if they're tall, do this, if they're not, do that. That's kind of like our independent variables impact on our dependent variable. So maybe hopefully this is starting to look familiar, like that Modelese reading I had you do, okay? So here, again, we have two separate ones. We want to try to put them into the same graph. So to do this, we are going to go to regression, which is the 1, 2, 3, 4, 5th button at the top. And in this class, we are always going to stay in the classical area. You'll notice that there are different options for most of these. We, in this class, will always cover classical. That other stuff, advanced stuff. So once we are in regression, the drop-down menu, we're going to click on correlation. This opens up a new input menu for us, and it opens up a new spot for the output. So in this case, we want to make a scatter plot of our two variables, one of which is thumb length and one of which is height median split. Right? Those are our two variables we're interested in. Now, what it's running here, this is running what's called a correlation. I'm just going to go ahead and turn that off because we're not quite there yet. Okay, but it's coming soon. But what we want to look at here is we want to see both of these as a plot. So we're going to go down under, on the right hand side, there's the plots menu. Click scatter plots. Takes a moment, but then you should see, looks a little funky. Um, but we see here is our scatter plot. This plot right here is actually showing all of the same data as these two histograms combined. So the information that's here, the shorter half of the class, these numbers are represented here, right? So the numbers that we saw here from 30 to about 65, we can see those are in group 1, the short half of the class. Theirs go from about 30 to 65, right? So we can see it's just been plotted. They're all right here, stacked on top of each other. Now, the tall half of the class runs from 45 to 80. If we look, the tall half of the class here is represented by this 2 group. And if we kind of look across, that's, yep, about 45. And this should be about 80. So sort of what we've done is almost, if you imagine, taking one of these histograms, sort of, if what you imagine, it's kind of like if you take one of these histograms and you flipped it on its side. Oh, I wonder if I can do this in Word. That might be fun. Okay, so let's take this guy, bring it down here. All right, so let's see if I can make this work. Okay, so if you imagine if we sort of like rotated this one, and then we squished all of those points down so they were all just in one line. But here, where there's a big stack, we would just have a whole bunch of circles would appear in here, right? It'd be more thick in this middle section, and there would be fewer out here. Okay? So this is sort of like what we see right here. You see how it's really thick in the middle and there are only a few on the outsides? That's exactly what we've done. We sort of rotated this and squished it into a line. This right-hand group, same idea. If you take this tall half of the class and you sort of squish it all down so it's all in a line and then flip it on its side, so 80 is at the top and 45 is at the bottom, then we can see that group here. So we have our we have our scatter plot, which shows the same information as the histograms that we had previously. But you'll notice some things that are different about this scatter plot. And so what I want you to respond on this question is, what do you see with this scatter plot? What do you think? Is it as helpful as looking at these two separate histograms? What's good about it? What's bad about it? Because there are kind of pluses and minuses. So go ahead and just give me your thoughts on, what do you think about this scatter plot versus our two histograms? It is all together in one, right? So that is a plus.